Welcome to Global Feed. Please subscribe and hit the bell icon for more breaking updates. Hello, I'm Chris Hadfield. Down here on Earth, sound is everywhere, a constant companion. But in space, we're told there's only silence. Yet, that's not the whole story. Space is alive with vibrations, radio waves, and plasma currents, a hidden symphony. Today, we'll listen to the real, unsettling sounds of the universe, captured by our most advanced probes. So, put on your headphones. What you're about to hear is the true soundtrack of the cosmos. Our first stop is Saturn, the ringed giant. Cassini's instruments picked up radio emissions from Saturn's magnetic field, transformed into haunting audio. The result? A shifting, whistling chorus, an ethereal song echoing across space. These sounds reveal Saturn's auroras and even help measure the length of its day. Each whistle is a testament to the planet's turbulent, invisible forces. It's not wind or weather, but plasma and charged particles dancing in a magnetic field. Listening to Saturn, you feel its immense scale and eerie presence. Even the most tranquil worlds can hide unsettling noise. Next, we approach a black hole in the Perseus galaxy cluster. Black holes are the definition of silence, but the space around them isn't. Astronomers detected pressure waves, sound waves, rippling through superheated gas. Scaled up for human ears, these waves become a deep, guttural roar. It's the sound of unimaginable power, a cosmic monster warping reality itself. In the dense gas of a galaxy cluster, sound can travel and the universe finds its voice. The black hole's roar is a chilling reminder. Space is not as silent as we thought. It's the voice of absolute, inescapable power. Some of the strangest space sounds come from Earth's own magnetosphere. High above us, plasma waves create chorus waves, a chorus of ghostly, chirping birds. Satellites have picked up these ethereal sounds for decades. They're generated as high-energy electrons spiral along magnetic field lines. The result is a dynamic, structured symphony, a conversation between Earth and the Sun. These waves accelerate electrons, forming the dangerous Van Allen radiation belts. Our planet's protective bubble is singing, and it's both beautiful and haunting. The ghostly choir above us is evidence of powerful, invisible processes at work. Now to Jupiter, the solar system's largest and noisiest planet. Voyager and Juno have recorded Jupiter's deep, unsettling moans. These guttural groans come from its immense magnetosphere, a particle accelerator powered by volcanic I.O. When converted to audio, Jupiter sounds like a colossal creature sighing in the dark. Juno's close passes reveal a cacophony of groans, whistles, and hisses. It's the sound of a world in constant violent motion. Jupiter's moans remind us of the raw power and alien nature of our solar system's giants. This is the soundtrack of a planet that never rests. In 2012, after a journey of more than 3 decades, Voyager 1 became the first human-made object to cross into interstellar space. This tiny spacecraft, launched in 1977, had traveled farther than anyone could have imagined, leaving behind the planets and the sun's protective bubble. As it crossed the heliopause, the boundary where the sun's influence fades, Voyager 1 entered a realm no spacecraft had ever visited before. Out there, in the vast emptiness between the stars, Voyager 1 heard something unexpected. A low, persistent hum, echoing through the darkness. Its sensitive instruments picked up the faint, ghostly vibrations of interstellar plasma, charged particles drifting between the stars, revealing a hidden layer of the universe we'd never directly sensed before. This background noise, a gentle but constant hum, is the music of our galaxy. It's always there, a steady signal that fills the emptiness, reminding us that even the void is alive with energy. The hum is like a whisper, carried on a sparse medium of charged particles, drifting endlessly through the interstellar medium. It's faint, but unmistakable, a sign that space is never truly silent. Occasionally, this quiet song is interrupted by louder bursts, shocks from solar storms and flares, sending waves of energy crashing into the interstellar medium, briefly raising the volume of the cosmic hum. Listening to these sounds is profoundly moving. It's a lonely, haunting melody from the edge of the sun's influence, a reminder of how far Voyager 1 has traveled, and how small we are in the vastness of space. The discovery of this hum confirmed that Voyager had truly crossed into interstellar space, venturing beyond the last traces of our solar system and into the unknown. It's the quietest, most distant sound humanity has ever recorded, a faint echo from the farthest reaches of our galaxy, captured by a lone spacecraft billions of miles from home. The great beyond isn't silent, instead it hums with the subtle, mysterious music of the Milky Way, a cosmic symphony that Voyager 1 was the first to hear. The sun may look calm from our vantage point on Earth, a steady golden disk in the sky, but beneath that serene appearance lies a violent churning sphere of nuclear fusion. Its surface is a roiling sea of plasma, constantly shifting and erupting with unimaginable force. Solar flares and storms erupt with little warning, unleashing torrents of energy that can dwarf anything we experience on Earth. These outbursts send powerful radio bursts and streams of charged particles racing across the solar system, sometimes reaching our planet and affecting satellites, power grids, and even the northern lights. When scientists convert these radio bursts into audio, they sound like sharp, explosive crackling, an eerie, otherworldly noise that captures the raw, untamed energy of our star. It's as if the sun is speaking in the language of storms. Each crackle represents a magnetic field line snapping and reconnecting, releasing energy equal to millions of hydrogen bombs in a single instant. These magnetic tempests are the true heartbeat of the sun's fury. The sun's fury is a harsh electric storm, a stark contrast to the gentle warmth we feel on our skin. Its surface is alive with flickering plasma arcs and surges of electricity, a reminder of the star's volatile nature. By listening to these radio bursts, scientists can study the sun's eruptions in real time, helping us understand the complex forces at play and providing early warnings of space weather threats that could impact our technology and daily lives. The sun's crackle is a constant reminder of its immense, unpredictable power, a force that shapes our solar system and sustains life, yet can unleash chaos in an instant. Our star is not silent, it's a tempest in constant eruption, a cosmic symphony of energy and motion that never truly rests. Mars, long thought silent, now lets us listen thanks to Perseverance's microphone. When a dust devil passes, the rover records a low wind rumble and sharp metallic twangs. Each twang is a grain of Martian sand striking the rover, a strange, percussive music. It's an intimate, immediate sound, transporting us to the surface of Mars. Unlike distant electromagnetic waves, this is true sound, pressure waves in the Martian air. These recordings reveal the dynamics of Martian weather and dust devils. Hearing Mars is like standing in an alien desert, surrounded by swirling red dust. A new sense, hearing, opens a new dimension of exploration. Our final sound comes from the ghosts of dead stars, pulsars. These are the remnants of once massive suns that ended their lives in spectacular explosions, leaving behind incredibly dense, spinning cores. Pulsars are among the universe's most fascinating and mysterious objects, acting as cosmic lighthouses in the vast darkness of space. When a massive star collapses in a supernova, its core is crushed into a neutron star, which can spin dozens or even hundreds of times per second. As it spins, it emits powerful beams of electromagnetic radiation from its magnetic poles, sweeping across the cosmos like the beam of a lighthouse. If one of these beams happens to sweep past Earth, we detect it as a rhythmic, echoing pulse, a cosmic metronome that never misses a beat. These pulses can be so regular that they rival the precision of our best clocks. In fact, when pulsars were first discovered by Jocelyn Bell Burnell in 1967, their signals were so precise and regular that astronomers briefly wondered if they might be messages from intelligent life, earning them the nickname Little Green Men. Each pulse is the heartbeat of a dead star, echoing through the void, a reminder of the star's former glory. The Crab pulsar, for example, pulses 30 times a second, its light and energy still reaching us nearly 1,000 years after the supernova that created it. Pulsars are more accurate than atomic clocks, and their sound, when converted to audio, is both mesmerizing and haunting, like the ticking of a cosmic clock echoing through eternity. Scientists use pulsars to test the laws of physics under extreme conditions, search for elusive gravitational waves, and even navigate spacecraft across the vast distances of deep space, using their signals as a kind of interstellar GPS. In the end, the lonely rhythmic beat of a pulsar is the universe's way of keeping time. A ghostly pulse echoing for eternity, reminding us of the incredible life and death cycles that shape the cosmos. From Saturn's eerie whistles to the heartbeat of a pulsar, we've heard the universe's hidden soundtrack. Space isn't silent, it's filled with a ghostly chorus, deep roars, and a constant hum. Each sound tells a story of power, scale, and time, reminding us how much remains to be discovered. These are just the whispers we've captured. Countless others await. The next time you look up, remember, the cosmos is singing, roaring, and humming, and we're finally learning how to listen.